All right, ladies and gents, let's look at our last couple examples here. Now, again, our goal is to look at this without using the Pythagorean theorem. On this one, you actually could if you needed to, because you're given two sides. You're given the hypotenuse and one of the legs, and you could use the Pythagorean theorem to find that missing leg. However, we also can recognize that it might fit that particular form we have of being 3, then this would probably be 4, and this would be 5. So it fits this if this is a 3, 4, 5 triangle. Okay? So if we know that, then we already got side A, which is 4. Okay, that would be side 4 right there. Now, the two angles then, one's got to be approximately 37, because that's the shorter non-right angle in a 3, 4, 5 triangle, and then approximately 53 the other one, which goes where? Well, again, if you take a look, 3 is the shortest side of the two. We've got 3 and we've got 4. So 37 will go across from the shortest side. So B here has to be approximately 37 degrees because it's opposite the smaller of the two legs. So B is approximately 37 degrees. Now it's not exactly, it's about 37.1 I believe, but we'll just put approximately 37. So the 5 is opposite, it's the hypotenuse, it's opposite the right angle, which leaves us then, and I'm going to erase this so we can get out of some of this stuff we have here. So then that leaves us with A. Well, again, A is opposite the longer of the two legs, so it is the longer of the 37-53 angle relationship. So this is approximately 53. Okay? Or once you found that this up here was 37, you could take 180 minus 37.1 and get approximately 42.9. We just call approximately 53. So ladies and gentlemen, there you go. There's how you use the side angle relationships of a 3, 4, 5 triangle. Now the last thing I want to do is look at a real life application here, and it's just basically the same as what we've been doing. So if you want to take a minute and see if you can do this, go ahead and just pause the video, read the problem, maybe write down some stuff or make note of some stuff, and see if you can figure out what L is here. What's the length of this connecting pipe right here? They want to know what L is. So go ahead and pause the video and see if you can do that. Okay, it says parallel pipes are connected with a 45-degree fitting as shown below. This is a plumbing problem. So calculate the length of the connecting pipe from A to B round to the nearest tenths. Now, the key thing I notice here is it says 45 degrees. And if you take a look, here's our triangle right here. Okay, and this is a 45-degree angle. This here is a right angle. So what that makes this has to also be 45 degrees. All right? So I'm going to erase this for a second, but this tells me that I'm dealing with, ladies and gentlemen, a 45, 45, 90 triangle. Okay? And again, I'm going to just kind of draw this in. There's one side of the triangle. There's the other side of the triangle. And what we're having to find is this right here, this. Well, if you notice, ladies and gentlemen, that's the right angle. The length of that connecting piece is opposite that right angle. So what that tells me then is that this is the hypotenuse. This right here is the hypotenuse. Your two legs, and again, if this is 45 and this is 45, we just found that out. And by the way, you can tell that anyway because the offset piece here, this piece, and this piece are the same length. So this is an isosceles right triangle, which is a 45, 45, 90 triangle. So in essence, what we're trying to do again, we're trying to find the hypotenuse. All right? Now, we know the lengths of the legs, they're 8.5 inches. So if you go back to your relationship, the hypotenuse in a 45, 45, 90 triangle, its length is equal to the length of one of the legs, because they're both the same, times the square root of 2. All right? So if we just fill in what we're looking for, what we know, the hypotenuse we labeled as L is equal to the length of one of the legs, which is 8.5 inches, times the square root of 2. Or, again, in your calculator, it's 8.5. The square root of 2 is about 1.414, and so forth. So if we multiply those together, the length, then, of the connecting pipe should be approximately 12.0 inches if we go to the nearest 10. And remember, you need to put a label in there. I was going to say, some of the problems we've been working on, the sides don't have any labels, so you don't have to have any labels if you don't need to. But in this case, ladies and gentlemen, the sides do have labels. They're inches. That's what those double tick marks are. And so our length of our connecting pipe should be around 12 inches. It should be approximately 12 inches long in order to connect this upper pipe with this one with a 4.5 inch offset, a 4.5 inch run. Okay? So hopefully that gives you enough information, ladies and gentlemen. So again, I've got the Blue Book exercises online. I made a copy if you don't have your book, or if you don't want to use it, that's fine. But the worksheet, a review of the Pythagorean theorem, again, I've got that online. If you want to do that, if you want to do some of the problems just to get you familiar again with the Pythagorean theorem, that's okay. And then what I would like you to do is those problems on pages 646 to 648 in the Blue Book, or 623 to 625. C number 11, 12, 14 through 18, D 12, 16, and 17. Okay, they all have to deal with these special right triangles. If you do that, ladies and gentlemen, it does make your work a lot easier. So if you have any questions, give me a yell. I hope everything's going well. I hope life's going great for you. I hope you're not going stir crazy, but the biggest thing of all is meeting, give me a yell, email or so forth, or, ladies and gentlemen, you can give me a call. My phone numbers are always in my emails. So have a great weekend. Stay safe. Have a great week. Stay safe. Stay healthy.